Every comet bound to our sun eventually turns back toward it. On July 1st, 2025, the Atlas Survey Telescope in Chile caught one that never will. If this wanderer was already moving before our sun even existed, what could possibly still be tracking it? It moves at 58 kilometers each second. That is fast enough to break free of the sun's gravity, faster than any comet born in our own solar system. Astronomers name it 3I Atlas, the third interstellar visitor ever confirmed entering our solar system. It does not know we are watching. No planet sent it here, and no star will ever claim it. The dark delivered it unannounced. This is not a story about a rival. It is a story about a door that will not open twice. 2 visitors came before this one. In 2017, astronomers watched Oumuamua tumble past and vanish before anyone understood what they were even looking at. In 2019, Borisov followed, a comet from another star, gone again within months. This one carries the name 3I Atlas, and the name is not decoration. The letter marks it as Interstellar. The number marks how rare this still is, only the 3rd confirmed door we have ever caught opening from outside our own solar system. The Atlas Survey, officially the Asteroid Terrestrial Impact Last Alert System, exists to catch objects heading toward us, not past us. Its telescope in Rio Hurtado, Chile, reported the first sighting on July 1st, 2025. But once a discovery exists, astronomers do what they always do. They search the archives for anything they might have missed. They found it. Pre-covery images, buried in old survey data traced back to May the 7th, 2025, 55 days before anyone noticed at all. Something else got here first. We spent nearly 2 months sharing our solar system with a visitor none of us knew was there. That is a sobering thought and an exhilarating one. The same blind spot that let us slip past became the reason we now hold one of the most complete records gathered. Every fresh image, every re-examined archive has turned an accident of timing into an extraordinary gift. A 2-month blind spot in our own backyard already changes what you thought you knew about the sky. Hit subscribe and turn on notifications, so the rest of this story doesn't slip past you the way 3I Atlas almost did. By August 2025, one number was doing all the talking, 46 kilometers. That was the diameter Harvard astrophysicist Avi Loeb read into new data from the SPHEREX Space Observatory, a nucleus so large, he argued, that no ordinary comet should exist at that size at all. He had already floated a livelier explanation that 3I Atlas might not be a comet at all, but a technological probe. Imagine trying to photograph a lit candle through thick fog. Its glow spreads so wide across your lens that the flame could be an inch away or a mile away. The glow alone cannot tell you which. That is the trap 3I Atlas set for its own measurement. Its cloud of dust and gas burned so bright that no one could see where the glow ended and the body began. Loeb's headline number quickly drew public challenges. Other astronomers, including Penn State's Jason Wright, argued the calculation mistook scattered light for solid surface. The wrong measurement, wrong reason. The bigger claim was also the wrong one. The real answer took longer and demanded a quieter kind of patience to earn. Between December 2025 and January 2026, Hubble Space Telescope observations finally separated the faint nucleus from its own bright halo. The result showed a solid core measuring 2.6 kilometers across, give or take 400 meters. Far smaller than the headline, still 40 times heavier than 2I Borisov, the interstellar comet before it. How do you correct a headline nobody wants to lose? Slowly, carefully, one patient measurement at a time, the least electrifying way possible to arrive at something this extraordinary. In December 2025, the James Webb Space Telescope found something no one expected in the comet's cloud: methane. Sublimating that far from the sun, methane should not survive long enough to be seen. And yet, there it was. Martin Cordner, the astronomer at the Catholic University of America who led the Webb observations, put it plainly. The comet's carbon dioxide, measured against its water, sits among the highest ratios ever recorded in any comet. Not unusual, among the highest ever seen. Then came something more astonishing still. The Very Large Telescope in Chile detected atomic nickel vapor drifting from 3I Atlas at 3.3 astronomical units from the Sun. That is a distance so cold that nickel has no business sublimating at all. Its chemistry belongs to no sun we know. NASA astrochemist Stephanie Milam offers one explanation. Billions of years adrift through the lightless dark may have baked a crust onto 3I Atlas, roughly 15 to 20 meters deep. A shell cooked by starlight that never touched a single star. That crust converted plain carbon monoxide into the carbon dioxide now venting from its surface. It also stripped away the simpler carbon chains found in every comet born inside our own solar system. Spectroscopy also shows a deep, reddish surface hue, the fingerprint of organic material irradiated for eons. This is not a comet running low on fuel. It is a comet wearing the scars of a journey no solar system comet has ever had to survive. None of this settles how old 3I Atlas actually is. It only raises the stakes of that question. To imagine an object older than nearly every star in our galaxy means letting go of what age even means. This is a species that has only existed for a few 100,000 years. One team, led by astronomer Rebecca Bannister, modeled the comet's motion against the Milky Way's ancient thick disk. That is the slow-moving halo of stars formed soon after the galaxy itself took shape. Their answer: 3I Atlas could be as old as 14 billion years, nearly as old as starlight itself. Two witnesses to the same event can reconstruct it in opposite ways. One assumes where the story began. The other measures only the speed and direction happening right now. A newer study took that second approach, measuring the comet's present motion through the galaxy without assuming its birthplace at all. Its answer favors a different history entirely, a birthplace in the galaxy's faster, younger thin disk, with over 96% confidence. Both models rely on real instruments and real mathematics. They still disagree. Which disk, which age, which truth? Even now, the argument has not closed. One widely cited estimate published this year still places the comet's age near 12 billion years. Our own Earth, for comparison, is 4.5 billion years old. No side has produced the one thing that would finally settle it: a physical sample. The gap between these two answers is not academic. It decides whether this comet is merely older than our Sun, or old enough to have drifted through the galaxy since long before any sun like ours had even formed. Until then, 3I Atlas keeps two histories alive at once, a genuinely miraculous uncertainty drifting into the dark, indifferent to which we decide to believe. Every measurement so far has been about one object. The next one is about all the objects we are not seeing. In a 2026 paper, astronomer Avi Loeb and co-author Mauro Barbieri, calculated something that has nothing to do with size or age. It has everything to do with how crowded interstellar space turns out to be. Their estimate, at any moment, more than one object the size of 3I Atlas sits within 4.5 astronomical units of the Sun. That is closer than Jupiter. It means the space between the planets is not a boundary. It is a corridor, already crowded with traffic we cannot see. Imagine driving down a dark highway on a foggy night, certain you are the only car for miles. Other headlights pass within arm's reach on either side, hidden completely by the fog, never once switching on. That is the neighborhood we live in. Astronomers once described interstellar space as an empty, unbroken vacuum, a void with nothing in it worth naming. 3I Atlas is proof that description was never true. Traffic like this doesn't announce itself. We may be about to find out. The Vera C. Rubin Observatory, still mid-testing before its 10-year survey even began, caught 3I Atlas in its own images 9 separate times. Days before anyone officially announced the discovery, not one person noticed. Rosemary Dorsey, an astrophysicist at the University of Helsinki, puts the observatory's future haul between 5 objects and 500. The void was never empty. We were only now learning how to listen, and the instrument built to keep listening is already switched on. In June 2026, the SETI Institute pointed the Allen Telescope Array at 3I Atlas, listening across a wide band of radio frequencies for any signal. It heard nothing. That silence, paired with chemistry matching nothing ever engineered by human hands, closes a question raised at the start of this story. 3I Atlas is not a messenger from another mind. It is entirely an extraordinary comet, natural, ancient, and utterly unrepeatable. Before the comet reached Jupiter, a Harvard-led team proposed something bold: redirect the aging Juno spacecraft to intercept 3I Atlas at closest approach. A member of Congress even wrote to NASA, urging the agency to try. But engineers said Juno's main engine was already failing, its fuel reserves too thin for the maneuver. We had the math to try. We didn't have the engine. On March 16, 2026, 3I Atlas passed Jupiter at a distance of 53 million kilometers, unphotographed up close and kept moving. By September, it will fade past any amateur telescope, sliding beyond Saturn's orbit and out of reach for good. We did not fail to understand 3I Atlas. We failed only to reach it in time. And there is a real sobering difference between the two. The universe does not pause to check if we are ready. It never has. But somewhere past Jupiter tonight, indifferent to whether we are ready or not, the next one is already falling toward us. This time, an eye is already open. The same observatory that caught 3I Atlas by accident now scans the whole sky every single night on purpose. Picture a wide instrument on a dark mountain top, its shutter never closing, finally awake to a sky we once assumed was silent. Proof, this whole time, that it has been alive.